Randy? Yeah, it's right back there. All right, once you have the essential question written down, you can put your pencil down, because what I'm going to write next, we're just going to talk about, it's just review from your history of life, and then I'll let you know when it's time to start writing again. So you don't need to write down what I'm going to write. Okay? I want you to think back to when you were about, do you have a question? Do you have all pass? Can you look for it, please? I want you to think back to when you were like 2 or 3 years old. I know. Well, guys, for you, it was more recent than for me, right? Okay, think back to when you were 2 or 3. Then I want you to think of when, what was the first number or numbers you were able to speak or you were aware of? 5, 10, and 20 as a 2-year-old? You could say 20? Thank you. Okay. Hall pass is right over there, Gabe. Right there. What was the first few numbers when you were like 2? What were the numbers you'd say?
2, 8, 6.
2, right? Or then you turned 3 and you knew the number 3. Because aunts and little ladies would come up to you and be like, oh, you're the cutest little thing. How old are you? And you go, I'm 2. And sometimes you'd hold on. So, yeah. That's how I said it too, because I couldn't say my R. So I'd say, I'm fui, because that's how I used to speak. So, you were only aware at that time of positive numbers, right? The counting numbers, 1, 2, 3, 4, 5, right? Again, you don't have to write this down, so I'll be erasing it. We're just reviewing your life of numbers. Can anyone tell me what these numbers are called? 1, 2, 3, 4, etc. Starts with an N. NA. Natural, there you go. Okay, and then after you're 2 or 3, then all of a sudden, like maybe a year or so later, you also understood the existence of 0 and your knowledge expanded. And you understood the existence of 0. Right? So, if we add in 0, what numbers are we in now? These are all real, but it has a specification for 0, 1, 2, 3, 4. Whole, it has a W for the whole. I mean, whole, it has the whole. The 0 is the whole. Okay, then, a year or so later, maybe 2nd, 3rd grade, you start realizing, oh, there's not just 0 and positives, there's also negatives. So all of a sudden we got negative. Okay. Some of you learned about negatives last year, it sounds like. Okay, so again, you started with this small wealth of knowledge called the natural numbers. Nope, you don't have to write this. Then your knowledge increased to the whole numbers. Then your knowledge increased again to include the integers, which we abbreviate with a Z for Z. Okay, then you learned, oh, there's not just pretty numbers. There's gross, ugly numbers. What are those types of numbers? Decimals and fractions.
Oh.
If the decimal is a terminating decimal or a repeating decimal, those can all be changed into fractions. What are those types of numbers that can be changed into fractions called? Starts with an R. There we go. Rationals. Then we also learned, and rational abbreviation is a Q. Then we also learned there were other types of decimals that weren't so pretty because they went on forever and there was no pattern. And they're actually opposite of rationals. Irrationals. Irrationals. Irrationals, we did this at the beginning of the year, yes. Irrationals are numbers such as pi or square root of 2. So every few years, your wealth of knowledge increases more. And all of these numbers are what type of numbers? Real numbers. There you go. Well, guess what? Today, you thought real numbers was all that existed. Well, today we learn there's more. We're going to learn if it's not real, it's fake. What's another word for fake that starts with an I? Imaginary numbers. And with imaginary numbers, we move into the field of complex numbers. Okay? So you thought you had it all with real. That's not true. Now it is time to pick up your pencil and write. I'm going to erase this all, and we will start taking notes on complex numbers. Okay. Well, imaginary numbers come from square roots. Okay, imaginary numbers. Square root of 9. Raise your hand if you know what the square root of 9 is. Don't say it out loud. Raise your hand if you know the square root of 9. Okay, let's test you. Jared, what's the square root of 9? And? Ah, right. There's plus and minus 3, right? Okay. That's normal. We understand that. Those are real numbers because 3 times 3 is 9, right? Also, negative 3 times negative 3 is 9, right? Okay, next question. What is the square root of negative 9? Keep in mind, square root means a number times itself has to equal negative 9. Is 3 times 3 ever going to give us negative 9? Okay, is negative 3 times negative 3 ever going to give us positive 9? No, because it has to be a number times itself. No. Square root is a number times itself, so the sign has to be the same. So that's why we have this existence of imaginary numbers, because we have a problem when we take square roots of negatives. At no time will a positive times a positive give us a negative. Also, a negative times a negative won't give us a negative. So, it is plus and minus 3, but it brings us into the field of imaginary numbers, which is plus and minus 3i. I means it's an imaginary number. Okay? There are 2 important things from imaginary numbers that you need to know. Number 1, the square root of a negative 1 is what letter? I. Good, we just did that. I. The square root of a negative 1 is I. So whenever you take the square root of a negative, you should have an I in your answer. Also, I squared is a number. Yep, what happens when we square a negative 1? What happens when we square a negative 1? What does squaring a square root do? It cancels out, right? So all that's left is the negative 1. So I squared is actually negative 1. Okay, put a fluffy cotton ball around this. This is your imaginary number Bible, or Torah, Quran, whatever you use. Okay, basically this is important. You need to make it stand out on your paper. Square root of negative 1 equals I. Also, negative 1 is I squared. 2 things you have to have memorized. Everything else we do today will be things we already know, except for we have this abstract piece to it. So, a complex number has 2 parts. A complex number is a real number plus an imaginary number. You guys in the second row having conversations? Can you have those after class, please? Real number plus imaginary number. So it'd be like an A plus a BI. Is an imaginary if it has an I. Can someone give me an actual number for A? Roll. What do you want? 7, okay? So 7 plus, who can give me a number for a B? Yeah, Phoenix? 6i. So this guy is in a complex number. It looks like a binomial because there's a real piece plus an imaginary piece. That's a complex number. Yes?
So you would use I as, like it would be like an X, like
Right. Because an X is changeable, it's a variable, it's going to be changed, but an I has a value. And the value of I is the square root of negative 1. Okay, so next thing, we're going to graph this, which we already know how to graph, so it's really nothing new. We're going to graph 7 plus 6i. Just imagine that that plus sign is a comma. Do you know how to graph the point 7 comma 6? Yeah. Randy? All of these would be I. I is the only thing that stands for imaginary. You won't have it. I's are used for imaginary only. Okay? It's a good question, though. All right. So when we graph, it's the same as before. We have a coordinate plane. This is actually called the complex plane. The x-axis represents our real numbers. The x-axis represents the real numbers. The y-axis represents the imaginary numbers. That's the imaginary axis. Okay? So, in our complex number, what piece was real? 7. So that means that first piece, the real piece, is our horizontal movement from the origin. So from the origin, we count over to the right how many spots? Good. 5, 6, there's 7 right there. And then the imaginary piece tells us a vertical shift from the origin, right? So we move up or do we move down for 6i? Good, because it's positive. 1, 2, 3, 4, 5, 6. And if we come across and up, there we go. That is our point on the complex plane, 7 plus 6i. It's very similar to the real plane where we have 7 comma 6. Right? Do you agree it's really similar to the graphing of 7 comma 6? Yep. Right. Okay. Now on a couple of your assignments you're asked to find the distance from the origin to that point. And there's a formula. The last period a few people have already been familiarized themselves with Pythagorean theorem. Has anyone learned Pythagorean theorem in here? Oh, we have a couple. Hakeem, do you know the Pythagorean theorem? You don't remember it. Okay. Phoenix? Great. A squared plus B squared equals C squared. That comes from right triangles. A and B, see if we drop this line here, it creates a right triangle, doesn't it? A and B are the legs, and C is the longest side, the diagonal, that's a hypotenuse. Oh, C squared. I forgot the squared there. A squared plus B squared equals C squared. So, the hypotenuse is C. We could easily solve this for C. Right now it's C squared. How do we get rid of the square? Square root. I've talked about that twice today. The inverse of squaring is taking the square root. So, please get that ingrained in your head. So we take the square root, we're just left with C. And we have A squared plus B squared. Now I'm going to put parentheses around A and B, just in case A or B is ever negative. We need parentheses. Okay, so we can find the length of, or the distance from the origin for that point by, the directions will ask you to find the absolute value. It'll say find the absolute value. Really what it's asking is to find the length of the distance from here, the origin, to the point. So if you were to find the absolute value of your complex number, we're actually just going to use the Pythagorean theorem that we just figured out and take the square root of it. square root of a squared plus b squared. And once you write that down, we'll actually put in numbers for a and b. So we have those numbers, a and b. So Raul already gave it to us, and was it Phoenix gave us the other one? Okay. So once again, this guy's our point. 7 plus 6i. What number is a that Raul gave to us? 7. Good. Plus, what number is b? 6. And then I, because that's the imaginary piece. So if we are to find the distance, we take the square root of, good, 7 squared, and then what? It's just the number b. So just 6. Just 6 squared. Okay? What is 7 squared? 49. And what is 6 squared? Okay, Hakeem, you have a question? Yeah. Oh, 7 plus 6i. Okay, if we add these two, we can do this without a calculator. Let's think. 49 plus 30 is? What's 49 plus 30? 79 plus 6 more is? 80. 79 plus 6 more. 85. There we go. Okay. What's the square root of 85? Is that a nice one like square root 81?
No.
No. So we need to go back to our lessons from the beginning of the year and do a factor tree and break it down. What times what is 85? Notice it ends in the 5, so that should be a nice clue for you.
No, 5 times.
85 divided by 5 is 5 times 17. Okay, do either one of these break down? No. If they do, you keep breaking down and pull out anything in pairs like we did at the beginning of the year. Okay, so this is our distance, square root of 85. Okay, so make sure you break it down. The absolute value, which is the distance from the origin, square root 85. Any questions there? Yeah, as long as it's broken down, and that one can't break down any further. So this is another formula you'll need to make sure you have on your paper. I believe you have 2, maybe 3 problems that you use that. At least 2. Okay? Alright, I think we're going to go to our second set of videos before we add, subtract, and multiply. Okay? So, Gustavo, will you hit the lights, please? Okay, let me turn this off really quick. Thank you. Make sure I get it up. Hey, that wasn't a very nice word to use in this class. Oops. Okay, here we go. Another Will Smith video. Who's seen Men in Black? Yep, okay, here you go. This actually relates to your lesson. I want you to think about it.
He's back! The light giver! All hail King! All hail King! Okay, can you see by the dawn's
You are the man who would be king of the train locker.
O good and gentle townfolk of locker C-18. Did I leave anything here?
Yes, the timekeeper. You left it to illuminate our streets and our hearts.
I've been looking everywhere for that watch.
Oh, merciful one! The clock tower!
No, I got y'all. It's cool. Here, check this out. Titanium case, waterproof to over 300 meters. That's banging, right?
Who are you, stranger?
Jay?
All hail King! All hail King! All hail King! And you see
Oh, merciful Jay, the keeper of on.
commandments! The tablet! The tablet! The tablet! The tablet! The tablet! We have lived by its word, and peace has reigned throughout our world. Pass it on to others, so that they too may be enlightened.
Alright, next clip that goes along with that. I want you to be thinking of how this relates to our lesson. Oops, I needed to fast forward to 30, 35 seconds. There it is.
Still sitting, Shiva? Want my advice? No. No advice, no talking, hell no.
I apologize for
Fellas, I
that.
swear, I'm fine.
I brought him over from Grand Central Terminal. Why you put them rats in my locker, man? I thought it would put things in perspective for you.
No, Kate, it's actually kind of sad, man. Really, we need to let them out of there. I mean, they need to know the world is bigger than that.
Still a rookie.
Sitting, Shiva?
Keep
Want my
thinking.
advice?
No.
How does this relate
No
to our
advice.
lesson today?
No talking, hell no. Fellas, I swear, I'm fine.
I brought him over from Grand Central Terminal. Why you put them rats in my locker, man? I thought it would put things in perspective for you.
No, Kate, it's actually kind of sad, man. Really, we need to let them out of there. I mean, they need to know the world is bigger than that.
Still a rookie.
Okay, one more time. Has anyone figured it out yet?
Want my advice?
No. No advice, no talking, hell no. Fellas, I swear, I'm fine.
I brought him over from Grand Central Terminal. Why you put them rats in my locker, man? I thought it would put things in perspective for you.
No, Kate, it's actually kind of sad, man. Really, we need to let them out of there. I mean, they need to know the world is bigger than that.
Still a rookie.
All right, we hit the lights, Gustavo.
Hey, how you doing?
Oops. Nope. No, that's it. Okay. How does that apply to our lesson of complex numbers today, Randy? Right. You used to think there's only these real numbers, but all of a sudden your field has expanded today, and you've learned that there's another set of numbers called imaginaries, which leads us to complex numbers. Okay, what were they doing in the video? Okay, so little aliens were living in a locker, and they thought that was the world. And Jay says, man, why don't you put them in my locker? You need to let them out. That's not fair, because they need to know that there's more to life than that locker, right? And then his partner Kay says what? Still a rookie. You don't know anything, because he kicks open the door that says, do not open. It's not an exit. Danger. He opens the door, and what do they find themselves? They themselves are in a locker within a larger world that they didn't know existed outside. So that's what we've found out today. There's this larger world of numbers. So we're going to now add and subtract, which you guys already know how to do. You started learning how to add and subtract early in life. Now where is my, here it is. That marker disappeared. Okay. Okay, continuing through your notes. Examples 3 and 4, we're going to find the sum and difference. Find the sum or difference. Example 3? Yeah, 3. Okay, starting with the sum. 7 minus 2i. That's a complex number, right? Because there's a real piece and there's an imaginary piece. We're going to add that to negative 3 plus I. Also a complex number because there's a real piece and an imaginary piece. Okay? Guys, you have already learned this. We already know how to add these because it's similar to combining like terms. Do you see like terms?
Distribute.
No distribute. That's when we have multiplication. We don't have multiplication. Yeah, what are the like terms here? Right. The real pieces are like terms, correct? Okay, so we add the reals. 7 minus 3 is 4. And then we have another set of like terms, the imaginaries. So if you will label yours with R's and oh, I guess I didn't really spell imagine, did I? Imaginary. Okay, imaginary. We have -2 here, but how many are here? 1. So for our i's, we have -2 plus 1 is -1i. And you can write the 1, but you don't have to. So this is the sum. Which, see, pretty much we already know how to do this. It's just combining like terms. Just with an abstract form that this I means that's imaginary piece. So this is a complex number. Yep, this is the answer. The real piece is 4. The imaginary piece is -1i. Okay, finding the difference is very similar, but with subtraction, you always have to be careful. Okay, subtraction, example 4. Let's see, where is it? I wanted to do this one. 8 plus 6i. Again, it's a complex number. Tristan, you write it down. Minus 8 minus 6i. 8 plus I subtract 8 minus 6i. 8 plus 6i minus 8 minus 6i. What's tricky about subtraction? When we subtract a binomial. What's tricky when we subtract a binomial? Right, because there's actually a number right here, right? Okay, someone else. What number is in between the two binomials? For the what? Ooh, it's not just 1, it's -1. And we have to remember that that changes the sign of both of these. So you have to distribute that sign in. And it's now not 8 anymore, it's -8. And it's not minus 6i anymore, it's plus 6i. Okay, the other one stays the same. Again, you can find your real pieces. Why don't you label R's under your real pieces? Tristan, label R's underneath your real pieces and add them up. 8 and -8 make 0. And then label your imaginary pieces, your imaginary parts. Okay, plus 12i. Now, writing 0 is just kind of silly, right? So this is actually 12i. Even though it's now a monomial, it's still complex because the real piece is 0. Yes? We did subtract, but when we subtract a -6, it becomes positive. Okay? Any other questions about example 4? We've added, we've subtracted. Now we're going to multiply. Okay, we are not doing division today. Just multiply, that's our last one. Okay? Example 5. Okay. 2 minus 3i times 4 plus 5i. Two complex numbers being multiplied to each other, which currently looks like a binomial times a binomial. How do we normally multiply a binomial times another binomial? Distribution. Yes. Good job, Jared. Okay. Carlos, how do we distribute? What needs to be distributed first? What? It's the Santa hat, the rainbow thing. Good. 2 times 4. What's that, Carlos? 8. Good. What else do we need to do with the 2? Good. 2 times 5i, which is 10i. A positive 10i. Okay. We're not done, though.
3 times 4.
Ooh, careful. -3i times 4, which is -12i. And -3i times 5i is
-15i squared.
Good, I squared. Just like x times x is x squared. Here we get negative 15I squared. Any ideas of what we would do after we do a double distribution? Like terms. So we've done that before. This is not news. Okay. In the middle we have 10I minus 12I, which is negative 2I. Now, here is the part you have, that's probably new. Look up top to your fluffy cotton ball at the top. Not the ceiling, guys. Even though I'm pointing up, doesn't mean look at the ceiling. I meant on the top of your notes. That was really funny. Like, 3 heads go, huh? And go up to the ceiling. On your notes, on the top of your notes, fluffy cotton ball. I squared is actually a number. What's the value of I squared? Negative 1. So, this currently is saying negative 15 times I squared. So we need to insert that in. Times negative 1. Okay, whenever you have an I squared, you can't leave it in your answer. You have to replace I squared with negative 1, which makes this positive 15. Again, we have like terms. We have 2 real pieces. 8 and 15 is 23. And you should write the real part first, and then the imaginary part second, and that would be the product. Okay? So we already know how to multiply binomials, so that's all the same. Just at the end, make sure you replace any I squareds with the numerical value, which is negative 1. Any questions? Okay, I'm giving you 8 problems to try tonight. You're doing everything we've done. You're simplifying square roots, you're graphing square roots, finding the absolute value, adding, subtracting, essentially 2 of everything we've just done. Starting on page 779, we're doing numbers 1 through 8. Page 779, 1 through 8. Remember, if you come to class next time with your assignment completely done, on time, what do you get? 5 extra credit points on your assignment. You only have to do 8. Please do your assignments on time. And just as a reminder, I won't be here next class.